When we talked about solving systems of linear equations with two variables, we had two special cases that came up. One was what's called an inconsistent system, and the other is what we called a dependent system. We can have the same two circumstances here. The only real difference is going to be in the way we write out the solution in the dependent case. All right, but I do want to take a quick look at both of them. So let's take a look here. This is going to come out to be inconsistent. So what I'm going to do is I'm going to start. I see I've got these y and minus y here. So I'm going to add those two together. So I'll do 2x plus y plus z equals 4. And I've got 3x minus y minus 5z equals 0. And if I add these together, the y's cancel. And I get 5x minus 4z equals 4. Okay, now I've made my choice, right? So I have to stick with eliminating the y's. So I'm gonna take the first equation, 4x plus 2y plus 2z equals negative 3, and I'm gonna double the last one here because that already has the minus sign on the y. Since I've got a plus 2y here, I know I need to have a minus, a negative value to cancel it. So if I do that, this is 6x minus 2y minus 10z equals 0. If I add these together, yes, the y's do cancel, and I get 10x minus 8z equals negative 3. All right, now hopefully you can kind of see what's about to happen. I'm going to take this equation, multiply it by negative 2, becomes negative 10x plus 8z. You can see right there how everything is about to cancel. Minus 8, add those together, and we get a false statement. 0 is not equal to negative 11. And that means the same thing that it means when we're looking at the two variable case. There are no solutions. This is an inconsistent system, and you can either write that no solution, or you can use the empty set. Now there is an indicator that this is what you're getting, right? So if you look back at these first two equations here, notice what happens if I double the second one. 2 times 2x is 4x. 2 times y is 2y. 2 times z is 2z. 2 times 4 is not negative 3. So right away, just the fact that I got matches on this side and I did not get a match on this side, that is a big red flag that this system is going to come out inconsistent. So when I first see one, I'm kind of doing that kind of thing in my head. I'm playing around. Okay, I see I've got a y and a 2y here. If I double this second equation, is that what I'm going to try to do for my elimination? And I'm kind of looking ahead to see if that situation comes up. So I've got a second example here, this one of what's going to turn out to be a dependent system. So let's take a look here and see what happens. And I really want to focus on how we write the final answer. So what I'm going to start off by doing is I see the z's over here. I've got this plus z and a minus z. Right, so I'll combine those two equations first. 3x plus 2y plus z equals 1, and minus 2x minus y minus z equals 1. If we add this together, the z's cancel, and we get x plus y equals 2. Now I've made my choice, right? I have to continue eliminating z's. So I'm going to double the second equation, multiply this by 2, and it becomes 6x plus 4y plus 2z equals 2, and I'm going to combine it with the last one. Minus 5x minus 3y minus 2z equals 0. Add these together, z's are going to cancel, and we get x plus y equals 2. We got the same equation, right, which is a surefire indicator that what we have now is a dependent system. And if you really want to carry it through, right, multiply this one by negative 1, add it to this one over here. Everything cancels out. You'll get 0 equals 0. So how do we write our answer? First, just kind of bear with me, right? Walk through the steps here with me, and then in the end, I'll explain the motivation to it. So I'm going to take this equation and I'm going to solve it for y. Right? This gives me y equals negative x plus 2. Right, now I'm going to take this and I'm going to substitute it into one of the original three. It doesn't matter which one, right? We'll get a good result either way. I'm going to put it into the first one. So that'll become 3x plus 2 times minus x plus 2 plus z equals 1. So we'll distribute the 2. This becomes 3x minus 2x plus 4 plus z equals 1. And now what I want to do, because over here on this first one that I did, I solved it for y in terms of x. So what I want to do over here with this one is I want to solve it for z in terms of x. Right, so if I combine some like terms, this is x plus 4 plus z equals 1. Move the 4 and the x over. 4 plus z equals minus x plus 1. Z equals minus x minus 3. So these two equations here are what I'm going to use to get the answer. My solution will be the set of all points x, y, and z such that y equals negative x plus 2, comma, z equals negative x minus 3. All right, there's my answer. Now let's take a step back and think about why I did it this way, right? You want to be able to generate solutions to this. You want to be able to get ordered pairs, ordered triples, right? So what I've done here is I've set this up so that all you have to do is pick one value, right? Pick a value for x, right? If x equals 0, then I have formulas that I can use to get the corresponding values of y and z. So the point 0, comma 2, comma 3 satisfies all three of these equations. Whoops, I wrote that wrong. I was looking at here and thinking, wait a minute, that's not working. This should be minus 3. So there's a minus 3 there and a minus 3 there. There we go. That point satisfies all three equations. So that's why I want to do it this way. What I want to end up with here is the set of all points such that I have one variable in terms of a second, and I have the other variable, the third variable, also in terms of that second, right? That's what your final result should look like.